5 girls in a row of 6. So to determine the number of ways to arrange 3 boys and 5 girls in a row of 6, we need to calculate the total number of permutations. So we have 8 people in total, which are 3 boys and 5 girls, and we want to arrange them in a row. Since the order matters, we can use the concept of permutations. The number of ways to arrange 8 objects is given by 8 factorial, which represents the factor of 8. So 8 factorial equals to 8 times 7 times 6 times 5 times 4 times 3 times 2 and times 1 is equal to 40,320. Therefore, there are 40,320 ways to arrange 3 boys and 5 girls in a row of 6. The next question is, determine the number of ways to arrange the letters in the word bulgogi such that the vowels are always together. So, to determine the number of ways to arrange the letters in the word bulgogi, we can treat the block of vowels U or I as one unit. So now we have 5 distinct units, which is U or I as one unit, B, L, G, and G. Within the unit of vowels, there are 3 distinct letters, which are U or I. Next, we can consider the arrangement of these 5 units as the arrangement of vowels U or I and 2 consonants from the remaining B, L, G, G, since the 2 G letters are identical. So the vowels can be arranged among themselves in 3 factorial ways as there are 3 distinct letters. The consonants can be arranged among themselves in 2 factorial ways considering that the G letters are identical. So the total number of arrangements is given by multiplying the number of arrangements within each group. So we need to multiply 3 factorial with 5 factorial divided by 2 factorial, and we get 360. Therefore, there are 360 ways to arrange the letters in the word bulgogi such that the vowels of U or I are always together. So the last question is, there are 20 mangoes in a basket. 5 of the mangoes are rotten. A man randomly takes 6 mangoes from the basket. Find the probability that he gets not more than 2 rotten mangoes. So, to find the probability that the man randomly selects not more than 2 rotten mangoes, we need to calculate the favorable outcomes, which is selecting 0, 1, or 2 rotten mangoes, and divide it by the total number of possible outcomes, which is selecting any 6 mangoes from the basket. So first is selecting 2 rotten mangoes. The number of ways to select 2 rotten mangoes from the 5 available rotten mangoes is given by 5C2, which is the combination of 5 objects taken 2 at a time. Similarly, the number of ways to select 4 good mangoes from the 15 available good mangoes is given by 15C4. So, the total number of outcomes for this case is 5C2 multiplied with 15C4, and we get 13,650. The second one is selecting 1 rotten mango. So the number of ways to select 1 rotten mango from the 5 available rotten mangoes is given by 5C1. Similarly, the number of ways to select 5 good mangoes from the 15 available good mangoes is given by 15C5. So the total number of outcomes for this case is 5C1 multiplied with 15C5, and we get 15,015. The last one is selecting 0 rotten mangoes. So the number of ways to select 0 rotten mangoes is also the same, which is select 0 rotten mangoes from the 5 available rotten mangoes is given by 5C0, which is simply 1. Similarly, the number of ways to select 6 mangoes from the 15 available good mangoes is given by 15 C6. So the total number of outcomes for this case is 5C0 multiplied with 15C6, and we get 5005. So the total of these favorable outcomes we get is 33,670. Let's calculate the total number of possible outcomes. So the total number of ways to select any 6 mangoes from the 20 available mangoes is given by 20C6. It is the combination of 20 objects taken 6 at a time. So 20C6 is equal to total possible outcomes. So 20C6 is equal to 38,760. The probability is 33,670 divided with 38,760, and we get 0.8687. Hence, the probability that the man gets not more than 2 rotten mangoes is approximately 0.8687. So that's all from me. Thank you.